Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Maximizing Communication Efficiency in VANETs by using Fuzzy Interface System, FIS. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the routing protocol that we have designed specifically for the vehicular ad hoc networks, that is also termed as VANETs. So an intelligent fuzzy based decision model has been designed in order to select the cluster heads, and later the communication has been performed by finding a best route for transmitting the data among the vehicles in order to inform any of the activity that is happened. So let's move to the video. Before going to the code, let's see that what exactly we will cover into this video. In this video, initially we will talk about what are the application areas where the design system can be implemented. Then we will talk about that what are the code we have designed, how to execute it, which file is to be run, and what are the software requirements to execute that. Then we will talk about that what exactly the people are doing or the researchers are doing in the same domain, what are the problem identified in them, and what exactly the proposed work is. Finally, an experimental outcomes and the results will be analyzed. So let's talk about the application areas. The design protocol is for the routing protocol, which is basically transmitting the data wirelessly from one place to another. That is specifically for the VANETs over there in the code, but it can be implemented in certain regions. So wireless communication is the main domain under which the smart agriculture related, smart buildings, the intelligent transportation, medical, and specifically vehicles related, because one of the concern is of the nodes is the mobility, because they are moving from one place to another. So that is the main hold of the VANETs. So other than that, if mobility is not there, it can be implemented in certain communication areas like medical, internet of things, among the computers, the cars, the vehicles, and the ad hoc networks where request related data transmission and things has been done. So for this, what exactly we have done, we do have the code with us. So we will give you the folder name like this, under which there is a code folder in which all the files has been placed. The code designed is in MATLAB, so you must have the MATLAB software installed on your system. The MATLAB version that we are using currently is R2015B, so you can use 2015 or the above version, but make sure it should be a full version, not the trial one. So in order to run the code, you just need to copy the path of the folder and go to the MATLAB software, and you can just paste it here and press enter. When you press enter, you can see all the files are visible in the current folder, out of which you need to run main file. One is main file, another one is result calculate, which is for the different scenarios, and third one is the fuzzy system that is designed in order to take the decisions. So I'm sliding it to the side. So this is the main file. When we are going to the main file, in order to run it, we just need to click on the run button, so it will start executing the code. So let's see what exactly is happening among the system. So in order to run the code, you just need to click on the run button and it will start executing. Here you can see it is asking for the input, so I will click on the input button, the source button. So I'm giving 10 as a source node and destination as a, because total of the 10 nodes in each cluster is there, so it means there is a around 16 clusters and 10 nodes, so 160 nodes are there, so I'm giving 70th node as a destination one. So when I press enter, it will process the whole code and give you the route from 10th number node to the 70th number node grid, right? So this is how the code is to be executed. Other files I am also going to show you. Well, now let's see that what exactly we have done. So we were following one of the paper where the stable clustering for the VANETs on the highway has been designed. What they have done for the ad hoc networks, specifically for the vehicular ad hoc networks, they were doing the clustering, and the cluster head selection has been done on the basis of the distance scenario, that whichever the node is there. Second thing is the cluster formation is basically on the basis of the destination position, nothing specifically
only the direction angle is to be considered, and that can raise the issue of complexity, because as the nodes are moving from one place to another, so there is no specific direction where we need to find the things. So one of the issue that we identified is that most of the protocols designed for the VANETs are on the randomized based. Why not to form the specific clusters that can assist in reducing the complexity and finding the best route. Secondly, the clustered selection has been done on the basis of the distance scenario, which is the very old fashioned thing. So in the proposed scenario, we have considered multiple factors and a fuzzy controller, which is basically a rule based scenario where it can be extended, or the user defined rules can be given into that. So it is a soft computing techniques which is decisioning that whether which node is to be selected as a clustered within a cell. So these improvements has been made in the proposed methodology. So basically we are finding the best cluster head in within the cell to communicate among the vehicles. So one of the contribution that we have made in the proposed method is like, instead of being random in the network, we are splitting the whole network into small sections. Those are also termed as grids or mini clusters. Then we are deploying the equidistribution among the nodes. That means if the vehicle is moving from one grid to another, we must have the information, and accordingly we can decide that to which cluster it should transfer the data. So second thing that we have done, once the node, as I have given the source node, so it is a 10th node, so it will check the 10th node is in which grid. Then the before that it will evaluate the parameters of individual model and will select a best cluster head. The parameters that we have chosen to select the cluster head are given in the fuzzy. So it is the velocity of the node that is moving, acceleration at how much it is accelerated by the user, that uh, and the current position of the node. So these three factors has been considered in order to identify the trust factor, that whether that node is trustworthy to send the data or not. And then on that behalf, it is deciding that which node can be the cluster to in a single round to get the data from the vehicles in that particular grid and transfer to the main. And then for making the route, we are finding the nearest cluster head which is next to that particular grid where the vehicle wants to communicate, and form a route to the destination node block, right? So that what exactly we have done. We have given the area, nodes, and other factors. Even the speed of light is there in order to identify that at what velocity it is moving. So total of the 16 grids have been made, so 10 nodes in each grids are there for the initial stage. And then on the basis of the factors that we are calculating, we are getting the source and destination node and checking whether it is within the same grid or not. If it is so, it will ask me to enter again, because both should be in the different grids. Then on that behalf, we are reading the fuzzy system that we have designed in this file, and that file is used further for selecting the cluster head. Now for each and every grid, every time we are calculating the factors of the speed and the velocity on the random basis, and the distance among the nodes, and then it is giving us the weight values which we are saving in an array. And with the maximum selection rate that is given with the fuzzy, will be selected as the cluster heads. Then the communication among the nodes has been performed, where the node which is given as a transmitter and a source and the destination, the distance among all the nodes has been calculated, and finding the neighbors, that which block is nearer to those transmitter and receiver module. And on the basis of the grids that we have identified initially, the grids are the grids cluster has been taken as the main source of the main destination reach point. And while the point is not reached up to the destination, it is keep finding the nearest neighbor, and on that behalf it is creating a route up to the destination block. So this is the code that is giving us the overall route and the selection of the nodes. And in order to evaluate it, we have make the function of it. Here you can see the cal performance, which is totally same as of the main file, only giving we have passed it to a function to which the nodes and range can be given dynamically. So in the result calculate function, what we have done, we have varied the nodes and varied the range of the communication, so that every time we can pass these two factor one by one to the main code, which is quite similar in this file and this file. So only this is a function, and it returns at the packet loss, lifetime, and the affiliation factor, which we have calculated at the end in order to check that what exactly the impact on the different factors. So when I'm running this, you can see it will give us the different results. So by changing the node and the range, second is by changing the count of the vehicles and the range, we have evaluated the results and finally shows the result and compared it with the base paper, because they have chosen the same scenario where you can see by changing the node and the range, and second is by changing the velocity and the range. So we have considered both the factors and finally you can see the results that we have achieved. Let's have a look to it. So this is the performance of the proposed system with the packet loss rate. Here you can see at nodes 150 and range 200, this much packet loss percentage is there and so on. So as the nodes were around 450 and range was 200, it was having the maximum packet loss rate. Then this is the average CM lifetime, that how much for how much period the network gets stable, because it has the energy with them to communicate among the nodes. And this is the average number of re-affiliation times per vehicle, that how many times it node get affiliated for transmitting the data. And finally we did the comparison all the three factors with the traditional model KMB, scale and CBSC, which we have considered from the base paper. Here you can see we do have the three different results for the different scenarios, and finally compared for all the three factors for the average CM lifetime, packet loss rate, and finally the average number of re-evaluation time per vehicle. So this is the fuzzy based decision model, which is selecting a route on the basis of the multiple factors which were generally not considered by in multiple routing protocols. So further modifications are still possible, and much intelligent system can be designed to find the route, not specifically for the VANETs, can be implemented to many of the recent technology like FANETs, flying ad hoc networks, drone based routing, because those are the very crucial and popular domains now these days. So for more details you can contact us directly and can get the details. Thank you.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.